Hey guys, just wanted to go over a couple quick example problems on systems of inequalities today. Systems of equations we talked about the other day. Equations have equal sign. Inequalities are going to have one of four signs: greater than, less than, greater than or equal to, less than or equal to. So when I say a system of inequalities, we're talking about two algebraic inequalities with some combination of those signs. Here we have y is less than or equal to 3x minus 6, and y is greater than negative 4x plus 2. Now when we were graphing systems of equations, we were looking for the point where those two lines cross, so where my arms are meeting here. Now, it's a little bit different here. What we're looking for is called the feasibility region. The feasibility region is the overlapping area of your answers. Of both inequalities. So just like when we graphed equations, when we graph inequalities, we're going to do it just like we're doing 1, and then just like we were doing 2. And we did this about a week ago where we only graphed 1. We drew the line, and then we shaded one side or the other. So we're going to go over those. This form right here looks very much like it's in y equals mx plus b, which we call slope-intercept form. So I know a couple things from slope-intercept form. I know that my y-intercept is not just the number -6, but it's 0, -6, which allows me to come here and put the point 0, -6. And just as always, we are going to label our point 0, -6. Now, the other thing this tells me is my slope is 3, so I'm going to go up 3, and when there's no fraction, I just go over 1, and I have my second point. Now I have 2 points. That's all I need to draw a line. But I have to ask myself in an inequality, what type of line should I draw? And here, because I have or equal to, I know that I'm going to draw a solid line. Take my ruler out here. And draw my line. The other thing to remember is we want to label this point also, and that is 1, -3. And we also want to label the line, and that labeling the line shows me some understanding of which line is which. So y is less than or equal to 3x minus 6. Now because it's an inequality, we're not quite done yet. What we want to do is test a point. So for this line, I'm going to test 0, 0. Because 0, 0 isn't on the line. I put in a 0 for the y, that's where that came from. 0 is less than 3 times 0 minus 6. So here I have an equation or an inequality that I can solve. 3 times 0 is 0 minus 6, that gives me -6. Is 0 less than or equal to -6? Well, we know that is not true. So if 0, 0, which is this point right here, my test point, is not true, nothing on that side is true, and everything on this side is true. So we're going to come through and shade all of this. So this is one of them. Now we got to look at our other one, which fortunately is in the same form. It makes it nice and easy. We're going to look at this. We're going to say where our y-intercept is at 0, negative 0, 2. I'll put my dot there. I'll say that is 0, 2. I know my slope is negative 4 over 1. So I go down 1, 2, 3, 4, and over 1. Now it's important to remember that when you have a negative slope, you don't want to go down and left, you always want to go to the right. So we're always going to go to the right. We're just going to go up and to the right if it's positive, down and to the right if it's negative. Now I've got my 2 points. I can label this point also, it's 1, negative 2. And I can draw my line. And this is greater than, so I know it's going to be a dashed line. Now that I have my dashed line, I need to test a point for my second equation. Alright? And so I'm just going to put my equation on here, or my inequality on here. Y is greater than negative 4x plus 2. And we're going to test 0, 0 is still not on this line, it's to the left. Okay? So we're going to test 0, 0 again. Zero is greater than negative 4 times 0 plus 2. We just took our point 0, 0 and substituted the x coordinate for x and the y coordinate for y. This ends up being 0 is greater than 2. I also know that this is not true. So if 0, 0 is on this side of the line and it's not true, I know that everything on this far side is true. So I would actually want to come through and highlight all of this. So now when I have two intersecting lines, I can look at this and say it's kind of divided my graph into 4 distinct regions. I know where I shade is true. So over here where there's no shading, neither inequality is true. So for instance, 0, 0 was in this section over here, and it didn't make either one true. Here, in this section, only the black was true. So only y is less than or equal to 3x minus 6 is true. Up here, only the green one was true, so y, we've got only y greater than negative 4x plus 2 is true. And in this region over here, we've colored in both black and green, so we can say both inequalities are true. This is the answer. So when it asks you to solve by graphing, you actually put this graph on your answer sheet. And the way I would like to see it is to actually just take away the shading in these areas. so that the only area that is shaded is the area that both are true. And that becomes your solution. It becomes your feasibility region. Okay? And that's essentially how you graph two inequalities on the same coordinate plane, which we call a system of inequalities when we have our bracket.